Engineering is sometimes missing from an early childhood curriculum as a standalone content area. Often, it's included as part of overall science learning. Science concepts and engineering concepts do involve similar processes. Observing, classifying, describing, documenting, and applying knowledge certainly fit both teaching engineering and teaching science. However, engineering concepts are unique as they combine elements of both science and math concepts and apply them directly to real-world concerns. Because of this, it's both important and developmentally appropriate for early childhood teachers to support young children's engineering experiences. Consider aspects of daily life that you might take for granted. Transportation like cars or trains, buildings like homes, schools, or stores, and infrastructure like roads, sidewalks, bridges, or traffic lights. All of these things use math and science together to make our lives safer and easier. All of them are good examples of engineering concepts in the real world. As adults, we may not have a direct connection to the designs of cars, bridges, or buildings that we use every day. But in an early childhood classroom, young children can experience engineering concepts firsthand as they design, build, or solve engineering problems. Let's look at a typical engineering experience in the block area of an early childhood classroom. A group of children are building roadways with unit blocks for cars to travel on. One child, Dominique, describes a hill on her route to school and wants to add that hill to the roadway system that the children have made. She begins to build this by creating a ramp out of unit blocks to symbolize the hill. Another child suggests making the hill very tall and stacks several unit blocks under a long block. They test the hill by rolling a toy car down the ramp. Because the ramp is very steep, the car hits the bottom and falls off the unit block roadway. One child says, "It's making the car go too fast and it crashed." Dominique says, "That's too tall. My hill doesn't make our car go that fast. It should be lower." The group of children revise and refine their ramp design. With each version, they test out how quickly the car moves and how well it stays on the road. They continue through several versions of the ramp design until they create a ramp that allows the car to gently roll down the hill and safely continue onto the rest of the roadway. Scholars Evangelou and Baggiati identify engineering as an ongoing cognitive problem-solving process. They write, "As a way of learning, engineering thinking is a solution-oriented activity driven by purpose. The process begins with a question and is seeded with constant improvement, practical and material, through iteration and refinement." Dominique and her friends' experiments are a great example of engineering thinking. Rich cognitive experiences like building and rebuilding a ramp so that cars can roll down safely provide young children with opportunities to think deeply about engineering concepts and to utilize processes of engineering design and refinement, finding practical ways to solve real-world problems. These ongoing processes re-engage children in cognitive problem-solving over time, not just in the moment. Educators can support children's learning by planning extended activities and projects that allow children to explore engineering concepts across days and weeks, building on past lessons and observations to deepen understanding and encourage further experimentation. Would you like to explore engineering further? Check out the Engineering Explorers website for videos, lesson plans, and blog posts all about engineering in early childhood learning. Or visit our companion website, Early Science Matters, for more science and engineering resources, including a professional development module focused on engineering in early childhood.